Hey everybody, my name is Kenny Coleman. I am a senior technical marketing manager, product line manager here at VMware. And today you're going to be joining me as we go over Kubernetes for the virtual infrastructure admin new for 2020. Now, as I'd mentioned, as a technical marketing manager here, I focus on a few different things. I look at open source projects. I also have a very deep invested relationship with Kubernetes in general. And I am also heavily involved with Tanzu Kubernetes Grid. And that's really what we're going to be focusing on today, is looking more into the product side, because as I mentioned, this is new for 2020. I had given this presentation last year at a bunch of VMUGs. And really what this was really focused on was trying to teach you core concepts of pods, deployments, how to map my virtual infrastructure back to my Kubernetes infrastructure. So if I create a storage class, how does that map back to a data store? How does that map back to a virtual policy? And so we touched on a lot of that stuff last year. And so today, I'm going to kind of do a refresher of it just a little bit. But then what we're going to do is we're going to dive in and start looking at really the Tanzu portfolio and how this is really an overarching view of how you can start really integrating containers into your existing processes today. So one of the things we have to do is kind of level set. So if we look at what virtual machines did to server hardware, that's what containers are starting to do to operating systems. So virtual machines really democratized it. Creating the hypervisor created this ubiquitous layer that really didn't matter what kind of hardware you're running underneath. Didn't really matter vendors or anything like that. And containers are starting to take the same exact approach, whereas maybe an application doesn't necessarily need to be tied to a particular operating system. It just needs a few different dependencies. That could be a different kind of programming language. It could be a dependency to a type of database that needs to connect to, anything like that. But what we can do is we can wrap this all up in a container, and the container becomes really this construct that makes it super, super easy to use. It's lightweight, it's portable. You can go ahead, you can Google it. There's plenty of resources out there that says, what are the benefits of actually having containers? That's not what this is really going to be focused on today, but instead it's really going to be focused on knowing that really this is happening at a much faster adoption cycle. And so you have to be ready for it. And we'll kind of talk about what that looks like here in the next slide, because what we've seen is this bell curve or this hockey stick approach or mentality to containers, where if you remember back just when we all started getting into virtualization, for myself, it was around 2006 timeframe, 2007. Back then, trying to figure out like, oh, how do we do this physical to virtual migration? It was a daunting task. I mean, it really was. However, as we became more comfortable with virtualization and we virtualized our entire data centers at this point, we adopted for virtualization first policy, we became pretty complacent with it. And now we see containers kind of taking that next evolution of it, because we're already familiar with virtualization. This is just a new packaging mechanism. And so being able to take this and adopt it is happening at a greater pace than what we had seen with virtual machines beforehand. So if we look at just Kubernetes by the numbers, we can see that 4.3 billion is the projected market applications that are going to be in there by 2022. This is all, again, according to 451 Research. The link's down here at the bottom. You can go and check it out. 90% of the respondents says that they're running some sort of containerized applications today. 9 out of 10 are doing so in production. So maybe you're one of those, maybe you're not, maybe you're trying to figure out what all this means. And that's what we're really trying to help with our customers too. We're trying to help you understand this journey, and we want to help you be a part of it too. And I mean, you can just see the active number of contributors that are happening to the repository on GitHub. This is just the nature of just being open source, and having something open source makes it freely accessible and available, and really removes a lot of the friction to adoption, because you're able to use it and be able to do it at a much faster rate of pace, because you can get it stood up in your own infrastructure and kind of get it started. So again, you can just tell by the numbers alone that Kubernetes is starting to take over. So one of the things that when I was doing this presentation a lot last year, a lot of people were sitting in the crowd and in the rooms, and they were saying like, well, I don't think I need containers. Like, this doesn't really apply to me. And so I tried to figure out like, what bucket do you live in today, and what bucket could you be in tomorrow? Because this is really where we start seeing this starting to progress and starting to change. So if we think that maybe I'm in bucket 1, I don't have any development teams in-house. I buy all of my software off the shelf from independent store or providers, everything like that. I don't have access, or I don't need to it. I get binaries, I get images, whatever they are, and I just load them up into a Linux machine or a Windows machine. I'm off and running. Great. And maybe that's all you need to be worried about, because at some point, those bucket one, those ISVs end up becoming bucket two. If you remember what it looked like just a few years ago when you used to get binaries, and now all of a sudden, these independent software developers are now giving you OVAs. They're giving you images to go deploy into your vSphere infrastructure. So at some point, they made a switch that said it's a lot easier to package this up as a VM and let you go ahead and deploy this as an appliance in your infrastructure. Now, we're already seeing this change today where we have vendors are now swapping out these images or these OVAs and now saying, okay, here you go. Here's a container image. Here's a Kubernetes deployment manifest. You can go deploy this. So that's really the next phase of where you should be worried about is once these development houses are starting to rapidly switch over into adopting container technology, how does this look for me? How do I start adopting this? Because if you look today and you look online into Docker Hub already, IBM WebSphere, DB2 with Oracle, MySQL Enterprise, Splunk, these are all enterprise supported container images that are available from those vendors themselves. So that's where you have to start thinking, well, this is really starting to happen, and I've got to be ready. How do I implement these going forward as well? Then maybe you do have a little bit of in-house development. Maybe you've got some small applications, they're using .NET or something like that. You have access to Windows and you have access to the source code. This is great. This is a fantastic place to start. Windows is starting to get a lot more traction into the container marketplace. It's nowhere near the level of maturity as it is running in sort of a Linux fashion or what you would see in bucket 4, bucket 5. However, it is still available, is there. But again, you are going to have some dependencies. The idea is that if you are starting moving down this path, perhaps you try to figure out how do I make the .NET packages more Linux friendly. That is available today as well, so you can do a little bit more searching through there and kind of figure out how you can make that happen. Now, bucket 4 is legacy-ish applications. These are 5, 6, 7-year-old applications. They're still built with Linux primitives. They still have dependencies, maybe based upon a particular operating system or anything like that. However, they're easy to get started with because I can wrap these up into a container. They might not be very lightweight, but I can wrap them up in a container nonetheless, and I can have a nice operating runtime environment able to use them as well. And then I've got bucket 5. This is where I start moving along, and I am trying to be more cloud native in how I develop and how I make everything available to be able to be deployed as well. So you're using modern development languages. You're really Linux native here at this point. You're kind of actually building the source code, onto these particular images, but it doesn't really matter if it's based on Ubuntu or based on CentOS or anything like that, because a lot of these modern languages don't really care what kind of underlying operating system it is. However, all the dependencies of what are needed can be wrapped inside of it. So if you think of how these packages are built for Python, for Java, for Go, for Node, all these packages are ubiquitous. It doesn't really matter what kind of operating system I'm running on. So it makes it really easy to be able to deploy and get used. So really, at some point, you start looking from bucket 1 to bucket 5. And so bucket 1 is, again, you're on the total far end, no in-house development teams. However, at some point, you might be ending up in bucket 2 where your software vendors, where you're getting stuff from, is going to start handing you a Kubernetes deployment manifest. They're going to start handing you container images or something that you can, a container image you can download. You got to upload to your own registry, and you've got to figure out, how do I run this in Kubernetes? It's a real thing. It's going to happen. And then bucket 5 is where we have our own in-house development teams, and they are becoming a little bit more savvy, and they know how to deploy this, and they hand you everything, and then you've got to know how to deploy it as well. So to kind of just level set once again to understand exactly where Docker and where Kubernetes fits into this is that Docker is the lowest construct of just having a container, right? A running container. And what this does is it actually has my application. It has my dependencies in it. I can build the application. Now I have my image, and I say Docker run. I run that image, and now it's running, right? Super, super simple. And this is very easy to use at a small scale. If I've got 1, 5, 10 images or Docker container images, this is easy. I don't need something like Kubernetes. It's the same exact thing of saying, if I only have 10 virtual machines, why do I need vCenter, right? That's the same exact thing, because Kubernetes really starts coming out when you look at scale. When we start figuring out, okay, now I've got 25, I got 50, I've got 100, I've got 1,000 containers that are now running. How do I orchestrate this? How do I know which virtual machines have amount of available computing power that I can give to these applications? It's smart. It knows about that. How do I scale this as well? If I have an application that all of a sudden needs a burst of getting more resources or putting more instances up, how do I do that relatively quickly? Well, I can just say -I scale to X number. It's very, very good. And Kubernetes is very, very smart because it also can do failure recovery from hosts and everything like that as well. And I can do this all with a single application manifest, which makes it super, super simple by being able to apply it and make it happen, and being able to deploy this application into virtual machines spread across my Kubernetes cluster. So let's go over a quick little Kubernetes architecture review here to kind of, again, little level set. So the idea is that I first have a Kubernetes control plane, and the control plane has a few different components of it. First is the API server. Now, what this is going to do is this is going to front end and be there for all the requests for anything that has to happen with inside the cluster. So as a user, I talk to the Kubernetes API server whenever I want to do anything. When I want to create a storage class, when I do a deployment, when I do anything, I talk to the Kubernetes server because that's how it happens. Next is I got the controller manager. Now, the way that Kubernetes works, it runs on a desired state, and what it is, it says that as a user, I say, I want X amount of these running, and what the controller manager is going to do is it's going to provide a control loop that says, I'm going to continuously try to provision or make sure that Kenny has X amount of things running until it's at a desired state or whatever he wants. So that's where the controller manager comes in. Next is the scheduler. As you can imagine, what this does is that looks at what available resources are out there, and it will say, I can now deploy new pods, and I can watch for new pods that are not assigned. I can select those workers to run from them as well. Last is the etcd database. This is our key value store. This is analogous to what you would have as the SQL backend for the vSphere infrastructure. And what this is going to be doing is it's going to be holding the state of the cluster in itself. And this can be deployed in a stacked or separate deployment. For all intents and purposes, we're going to see stacked as kind of the most common thing. And what that means is that it is another service that's installed on the Kubernetes master, the Kubernetes control plane node, instead of being deployed on a separate VM as a separate service. So you would actually have to know how to organize and how to manage etcd on your own if it was outside of this. So the other cool thing about the control plane is that it easily scales out. Is that what we can do is that we can have multiple masters start front-ending this. So what we do is we would say, I now have all my etcd databases talking to one another, and then I front-end it with a load balancer. And what this load balancer will do is just do round robin between everything. And then at this point, not only does it just front-end this for API requests, but it will also assist you in upgrades for rollout. So if all of a sudden I needed to go from, say, 1.17 to 1.18 for Kubernetes, I could take down one of the Kubernetes masters. I could take 1.18, put it in there, and then sort of do this rolling deployment. So it makes it easy for you to be able to do these upgrades across your Kubernetes control plane as well. So the other thing we're going to look at is the Kubernetes workers. So with inside the workers, what we're going to do here is you're going to see that we have a few different pieces to it. So first is you have the operating system. This could be, most of the time it's going to be some sort of base of Linux. So CentOS, RHEL, Ubuntu, whatever it is, Photon. All right, Photon. So some sort of Linux-based operating system, and it's have a container runtime. Most of us know the idea of Docker. Docker is just one of many container runtimes that are out there. So we have our container runtime, and that's responsible for actually running the containers themselves. And then I've got the kubelet. The kubelet is what actually issues commands. It's almost like an agent that lives on every single one of our Kubernetes workers. And what this does is it issues the commands to actually create pods. Now, a pod is the lowest level construct of what I had talked about before. This is a pod can actually run one or more containers inside of it. And then there's another service called the kube proxy. Kind of sounds like network proxy. It's exactly what it is. It will actually be responsible for sending packets between network pods, over the overlay network between pods, as well as also being responsible for figuring out how do I get constant communication out from the pod to external resources that want that as well. And then all of this, as I mentioned, the kubelet is in constant communication with the API server. The API server, again, is the heart of all of this. And this is going to be responsible for, again, resource monitoring as well as heart beating. So just a nice little quick demonstration of what like a non-HA cluster looks like. I've got my Kubernetes workload, my control plane, that's or master, whatever you want to call it. And then I've got multiple workers. Each ones are running pods and all those different services inside of it. So again, super, super simple way to kind of just look and see how this works. So what's your challenge today? Well, what we look at is we have a very fragmented infrastructure. We could be running in vSphere. We've got different clouds and everything like that we're trying to run it in. So we have a lot of silos. We're spending a lot of money. Our policy looks very different across all of these as well. So how do we maintain and have this sort of like global view? And how do we kind of create something that is a consistent basis or consistent Kubernetes infrastructure across all of these at the same exact time? And so that's why we start looking at Tanzu Kubernetes Grid. What this is going to be doing is really start streamlining a lot of these multi-cloud operations, because we're going to be able to offer a more simplified installation. It's going to be automating a lot of this ability as well as also integrating with other kind of network and platform services. So one of the things that we've ultimately found when we started talking to customers is that when you want to start using Kubernetes, it's a little bit different than just doing standard vSphere. Because standard vSphere, we say, okay, well, I've got 32 hosts. Let's load them all up in a cluster, throw a bunch of workloads at it. We'll let DRS do its thing, and then it'll start balancing each other out. Well, it's a little bit different in the Kubernetes world, because we don't really see a whole lot of people creating one large or even two large massive Kubernetes clusters and managing it that way. Instead, what you see lots of smaller pockets of Kubernetes clusters. So you might have 10, 20, 30, 50, or hundreds of them. And when you're doing that, you've got to figure out a way, how do I consistently deploy these things and make it super, super easy? Because that's one thing that we've found a long, long time ago, is that it's really hard to build Kubernetes clusters. That's why Tanzu Kubernetes Grid exists, is because it makes it super easy to actually be able to do that. And so Tanzu Kubernetes Grid will be able to run Kubernetes on any infrastructure of your choice. So it is consistent across any cloud and across any infrastructure. We also have the ability to, and actually it is embedded into vSphere 7 with Kubernetes with VMware Cloud Foundation. So you're going to have a more native-like experience utilizing VMware vSphere 7 as well. And it's also a service that's a part of Tanzu Mission Control. Now, I'll go over each one of these in a little bit more detail so you kind of see where TKG really plays a role into each one of these different products here. So when we look at Tanzu Kubernetes Grid, I'm going to focus on what's called standalone. Now, standalone means a few different things. First is that we can run it on any infrastructure. That's kind of like the different profiles I just kind of talked about. But the left-hand side here is really what I'm going to be looking at, is running on any infrastructure. And so it's supported today on vSphere 6.7 Update 3, and then also on AWS out of the box. We also have support for VMware Cloud on AWS through VMC, as well as through edge deployments through TKG Plus subscriptions and offerings, which I'll kind of talk about here in a little bit later. Now, when we start getting into more of the personas of like, why do you want each one of these different pieces? It's because of the way that you operate. How do you operate your infrastructure? As somebody that is a hardcore engineer and as a builder mentality, perhaps you want to run it on your infrastructure. You want to own it. You want to figure out how this is built. It's another tool in your toolbox at this point. So it makes it easy for you to be able to deploy these applications. If it's inside of vSphere 7 with Kubernetes, I'm going to achieve a much more native vSphere experience. It's very turnkey, very easy to get started with. And not only that, is I get visibility inside of vSphere for what these clusters actually look like. I get new icons. I see all way new different things of what it looks like inside there. So it's really great for those that just want some more of a vSphere type of experience. And with with Tanzu Mission Control or TMC, TKG is completely abstracted. You don't actually know that you're using TKG because it's just a native function of the platform at this point. And really, you could almost think of it as like Kubernetes on demand, because you're able to go in and say, I want to create a cluster, click, click, next, go, and it automatically deploys a cluster for you. So TKG is just hidden under the covers. So the way that this really works, as I had mentioned, that Kubernetes is this desired state type of application. So as an operator, what I'm going to be able to do is I'm going to first deploy what's called a local control plane, or the TKG management cluster. And this management cluster is really just a small Kubernetes cluster. That's all it is. And as an operator, I say, okay, I want to create a new cluster. I want it to look like this. I want it to have one control plane node, 3 workers, and XYZ, whatever it is. I put this all in a desired state configuration or a YAML file, what I want it to look like. I apply this to the management cluster. And then from there, the management cluster, which is just Kubernetes, is actually utilizing Kubernetes to then deploy more Kubernetes clusters. So it's kind of hard to visualize, or maybe what I'm saying right here. However, what's happening is that I am creating new objects inside of there to actually make this happen. And so this is really how I was leading at, is that we have native Kubernetes API objects today. So we've got pods, we've got stateful sets, deployments, everything like that. That's what Kubernetes natively knows about. So how do we get it to know about new objects? Like, how does it know how to build virtual machines? How does it know how to build virtual clusters? Well, this happens because we create what's called CRDs, or custom resource definitions. And what this is just an extension of the Kubernetes API. We're now defining new objects that have a new name and a schema that we specify, and what we want to be able to do and how we want to extend Kubernetes. So what we can do is we can actually make Kubernetes understand anything, and we can use the declarative nature of Kubernetes to have it iterate on whatever it is that we want to achieve that desired state. And this, again, this is where Cluster API comes in. So this is your declarative model of actually making this happen and what these Kubernetes clusters are actually going to look like. So go ahead and check it out on there, because as I mentioned, Kubernetes knows about these different pieces. It knows about a pod, a replica set, deployment. However, with Cluster API, we're introducing more pieces to it. We're introducing a machine set, a machine deployment, and a cluster type of object. So now Kubernetes knows how to really understand how each one of these works. So we load Cluster API into it. And what we do is we load in more CRDs for the type of infrastructure that we're going to be talking to. Is it AWS? Is it vSphere? Because if we load in vSphere, now it knows how to talk to the vCenter API. It knows how to deploy virtual machines. It knows how to look for templates and look at catalogs and look at all that sort of stuff, right? So a lot of cool things are happening here underneath the covers, and really what you're talking about with Cluster API is all abstracted utilizing TKG. So you don't have to really get this down, get too low. I'm kind of just showing you for, kind of instructional purposes here, but TKG really abstracts everything that we have to worry about with Cluster API. So this is the most simplified way that I could show how you kind of build this process. So today we have a TKG CLI and a UI. This is a binary that lives on your local machine or on a virtual machine within inside your vSphere environment. What I do is I actually start by creating what's called a bootstrap cluster on my local laptop by saying TKG init. And when I do that, it creates this small kind cluster. It's called Kubernetes in Docker. So there's a Docker container that runs. It has Kubernetes installed, and then it loads the Cluster API CRDs, those custom resource definitions, as well as the vSphere components into it. If I'm talking vSphere in this instance. Now, once I have that, I'm also supplying it with some other, like a configuration manifest, as well as some environment variables, so it knows how to actually talk to my infrastructure. So once this is up and running on my local laptop, what it does is it actually talks to the infrastructure of my choice. So we'll say it's vSphere at this point. It's going to talk to vCenter, and then it's going to go and it's going to create a management cluster. Now, as you kind of see, there's a few different boxes on the right-hand side here. So the blue dotted line is supposed to represent my IaaS. The green dotted line is what's represented as just TKG. The solid green line says local control plane. Now, that local control plane, this isn't actually something that's visually represented inside of vSphere today. However, the TKG management cluster, as I had mentioned, is just going to be a Kubernetes cluster. So you're going to see a few virtual machines spin up that really consist and create this management cluster. So after the management cluster is up and running, then the bootstrap cluster on my local machine is then retired. It's no longer needed. And then I use the TKG CLI to talk to the management cluster to then deploy my TKG workload clusters from that point on. And I'll kind of talk about these local shared services here in a little bit. So this is where we start getting into more of these shared services. So with inside of here, as I'd mentioned already, we have our management cluster. We have Cluster API, which takes care of my lifecycle management. And then I've got the Kubernetes declarative API. So as a user, I'm going to utilize the TKG CLI to then create more Tanzu Kubernetes Grid workload clusters. Super, super simple. But now I want to figure out, how do I bring more services into it? How do I make this really more rounded, right? And by doing that, I want to kind of point out a lot of the open source pieces that we're bringing in here, because VMware is heavily invested into this open source ecosystem. So making sure that we are not only just setting ourselves up for success, but we're also contributing back and we're being good open source citizens at the end of the day as well. So our lifecycle management is all dictated upon Cluster API. Now, from there, we also have Harbor, which can be instantiated as a container registry. By default, this is nothing that is comes with TKG. However, it is open source, and you can get up and running pretty easily today utilizing a few different commands from Harbor as well. It's also a Harbor, I should mention, is a CNCF project, Cloud Native Computing Foundation project, heavily invested by VMware. It was actually started off as a VMware R&D project about 6 years ago, and now it is one of the most premier projects that are being adopted by lots of people around the world. So very happy to be involved with that as well. Next, we have Contour. Contour is your ingress controller. An ingress controller is what is able to take commands or HTTP GET requests from external providers and then route them into different services that are running inside of Kubernetes. We'll kind of see what that looks like in a little bit too. So next is you got logging, which you get FluentBit. I should also mention that Contour, FluentBit, Cluster API, these are all included as a part of Tanzu Kubernetes Grid. So logging actually gets you the ability to then configure log shipping to a centralized resource utilizing FluentBit. kubeadm is another open source component, also included with Tanzu Kubernetes Grid. This is going to be responsible for your cluster lifecycle components of actually building the cluster and actually like making them come together. Cluster API actually utilizes kubeadm underneath the covers. You don't see it, but it's actually utilized underneath of it. And then not only that is we'll be able to utilize kubeadm for some upgrade component capabilities later on down the line as well. We also have Dex that is going to be responsible for doing authentication to your Kubernetes cluster if you so choose to want to do that as well. If you want to have Dex connect to your LDAP or your OIDC connect provider, you can do that too. Again, all these components except Harbor are included with TKG as being supported. You also, other additional components, you got Containerd, which is your underlying container runtime. As I'd mentioned, we don't use Docker. We actually use Containerd. We have networking overlay utilizing Calico. You've got crash diagnostics in case something happens. Easy way to kind of get logs and ship them out of there. As well as we have provided OVA and AMI images that have all of the Kubernetes components built into them. So it's easy to build these clusters as well. So let's look just real quick at what this architecture looks like one last time. Pretty easy to kind of understand exactly how this is happening. Again, this is supported today on 6.7U3 as well as AWS and VMC, as well as some edge environments if you're wishing to do that as well. All right, so let's look at the Tanzu Kubernetes Grid service for vSphere. Now, this is all the new stuff that's now integrated into vSphere 7. So with vSphere 7, you are, should I say, this is all a part of not just vSphere 7, but as part as VMware Cloud Foundation. So as part of VMware Cloud Foundation, it comes with a lot of other components that are built into it. So it's a very tightly integrated type of offering. So having vSAN and NSXT, this gives you not only just the ability to have all your infrastructure wired up, ready and out of the box, and it's all going to work, but at the same exact time, there's other infrastructure services that I'll kind of talk about here in a little bit. So you've got the registry service where actually Harbor's integrated into this as well. It's a one-click deployment. There's the network service, so you can actually get your load balancers up and running. There's also the storage service that actually hooks back into vSAN and everything like that. So nice and easy to kind of get going utilizing VCF. So with the Tanzu Kubernetes Grid service for vSphere is that I can really start connecting both ends of not only just the DevOps side, but also the VI admin side. giving each individual their view that they want into their type of workload. So as a VI admin, I can actually go through into my what's called the supervisor cluster, which is the same exact thing as my management cluster in this case, if you think about it. So this management cluster, I can define the templates and the versions and everything that I want and resource quotas of what I can offer to my developers. And what do developers want at the end of the day? They want an easy way to be able to consume Kubernetes. And maybe they want to be able to deploy their own Kubernetes clusters. So giving them the option at this point to then say, okay, well, they can go ahead and they can create it. They can utilize the kubectl command line to actually talk to Tanzu Kubernetes grid service for vSphere and deploy their own clusters at this point. So making them really not only just the application owners, but as well as the underlying infrastructure owners of Kubernetes themselves. And that Kubernetes infrastructure just maps into the vSphere infrastructure that you own already. So it makes it really easy to use. It's completely upstream conformant. So we're not doing anything. It's just vanilla Kubernetes. So if it works on any Kubernetes cluster, it's going to work on a Tanzu Kubernetes grid cluster as well. And this is just an overview of kind of, again, what the service architecture looks like. So as a VI admin, I have my services that I know that are embedded into this and what I can offer up to my developers so they can take advantage of it. And then my developers can then start taking resources from the supervisor cluster. They can create new namespaces. They can create, or not new namespaces, they can create new Tanzu Kubernetes grid clusters. They can deploy their objects into it, whether they are Kubernetes applications or whatever it is. And they can get off and running as much as easy as they want to go as well. Now, the one unique thing that's available inside of vSphere 7 with Kubernetes is the vSphere pod service. Now, the vSphere pod service is the ability to run, I don't want to say the word native, but it is running pods directly on, almost like on the hypervisor itself. And so what this does is this gets you better performant advantages out of this. This also gives you what it says like here, a serverless type of experience. Now, the one thing to kind of also note is that this is also a little bit of a corner case. You don't want to do this with all of your Kubernetes workloads because this is really, again, it's not a Kubernetes conformant type of cluster. Instead, it gives you the ability to kind of have, again, take advantage of something that really needs a lot of high performance, whether it's a database or anything like that you want to run inside of a cluster. You can do it here as well. And you can, again, utilize this utilizing kubectl to make this all happen at the same exact time. So inside of this pod, this is, again, what the architecture looks like. I've got a new type of container runtime service. So it's not using containerd. It's something that's proprietary called CRX. And so inside of there is where we have our container engine as well as our containers that are running inside of our vSphere pod. As we had mentioned, we say that we can get up to 8% better performance than running just on bare metal alone. And then you've got the virtual machine service. So it's the same exact way as a user can go deploy Tanzu Kubernetes grid clusters. They can deploy vSphere pod services, but they can also deploy virtual machines directly from this. So it's a really cool, unique aspect of actually giving developers the control of actually going to be able to go and deploy virtual machines just as they would do with pods. So if they need a virtual machine for any sort of purpose, they can do that as well. And as a virtual infrastructure admin, I could define exactly what those images are, what the classes look like, resources, everything like that. Now, the namespaces is really kind of like one of those really neat key concepts that are coming into this. So at an SDDC layer, I can create multiple supervisor clusters. And then I also have this idea of what's called vSphere namespaces. Now, a namespace is a multi-tenancy kind of level. We're not really doing true native multi-tenancy yet. However, just to kind of know that we can now have multiple kind of applications or multiple types of objects running in each one of these individual namespaces. So say a namespace is dedicated to a certain BU or a particular developer or a particular application, whatever it is, you define whatever this boundary is. And you can say, okay, well, these namespaces have all these native pods running in them. Some of these namespaces might have virtual machines. Some of them might having Tanzu Kubernetes grid clusters. So I can do that utilizing a multitude of different things. So giving me really a whole lot of flexibility on how I am giving my end users the ability to then go and actually deploy the virtual machines from here. Actually deploy any type of service they want from here. So whether it's a Tanzu Kubernetes Grid cluster, a native pod, or a virtual machine, I can do this all within inside the namespace itself. So this is, again, kind of like the architecture of what it would look like. Super, super simple, once again. So as a platform operator, I can go and directly talk to vSphere itself, utilizing the workload control plane, utilizing the supervisor control image. I can create my supervisor cluster. That, again, is just a management cluster for this particular instance. And then from there, I can talk to vSphere and I can create TKG workload clusters. I can create vSphere pod VMs, and that's all going through the workload platform service as well. In the future, we actually will be able to take the TKG CLI and be able to have you deploy TKG workload clusters directly from the TKG CLI when it's talking to a supervisor cluster. Now, as I'd mentioned, there's a lot of clusters we're talking about coming up, a lot of Kubernetes instances. And so as you can see up on here, this is what it looks like to have 8 clusters. How do I manage 8 clusters individually? It's not easy, right? There's going to be multiple windows open. There's a lot of IP addresses to remember, or DNS names, a lot of service discovery that has to go onto it. So how do we make this a lot easier and easier to consume? Well, this is where Tanzu Mission Control really comes in, because what Tanzu Mission Control does is it delivers a multi-cloud experience. So it doesn't really matter if you're running on AWS, or if you have Tanzu Kubernetes Grid clusters running on vSphere, or even if you want to adopt potentially OpenShift clusters, you can bring this all and have this wide level view of everything, any cluster that you have that you're managing. So you have multi-cluster visibility, and you can actually allow multiple teams to come in, and you can have this new security context where individuals can now apply different policies to different Kubernetes clusters based upon what they're supposed to be doing. So this is really where the managed portion of all this really comes in. So with Tanzu Mission Control, I have the ability to now have cluster lifecycle built into it. It's just another component that's built into this as well. So being able to upgrade clusters and do rolling updates, I can do that via Tanzu Mission Control, or TMC. Identity and access. Again, this is all about applying policy down to individual clusters, and actually how do they communicate, or how do they get authentication mechanisms built into them. Same thing with audit and compliance, security and configuration, being able to apply those policies as well. TMC also gives you observability, so I can kind of start pushing out everything to a provider that I have associated with it. So whether I'm using Wavefront or I'm using anything like that, Splunk, you name it, I can actually start pushing out those diagnostic information out to some sort of aggregator. I also have data protection through a plugin called Valero, or a project called Valero. You can go check it out. It's another open source project that VMware is heavily invested into as well. And what this does is it gives me the opportunity to do backups of not only just stateless, but also stateful pods, and be able to store that data up into like an S3 bucket, and then be able to easily restore it at the same exact time. And so, as I mentioned, on the right-hand side is I can attach pretty much any type of cluster to it. And then we also have the ability to provision multiple types of clusters as well from it, and even more going to the future. This is kind of what the policy framework looks like. You have the ability to have security, audit compliance, data protection, health monitoring, all that sort of stuff built into it. This is an easy screenshot to kind of get an idea of what this looks like with Tanzu Mission Control. Should also mention that if you go and you want to purchase TKG, you actually get Tanzu Mission Control free for 90 days to actually go evaluate. So make sure you use those 90 days wisely. So when you start looking in here, you can see that it doesn't really matter what type of infrastructure I'm deploying it on. I can actually go and I can attach it to TMC. And then from there, I get an idea of whether it's been provisioned, if it's attached, and if it's provisioned, was it provisioned by TMC? And I was going to see the health of it. This is another good thing to kind of look at. There's another tool that's also built into TMC that's called Sonobuoy. And what Sonobuoy does is it looks for conformant testing. So if my cluster is passing a Kubernetes conformance test to say, like, does this look like the way it's supposed to be looking like? So this is kind of like a high-level overview, once again, to kind of give you an idea of where these all fit into one another. So underneath, you've got the API-driven infrastructure. From there, you utilize TKG CLI to actually create your local control plane, but that management cluster is really the workhorse here. What this is going to be doing is saving the state of what all your other workloads are going to be looking like. And then I utilize Cluster API to then provision all my workload clusters, and it can go from N to infinity, depending on how big you want this to go. You also have the ability from there as you put your workloads on top, and then you got Tanzu Image Control, which attaches them all. And then you also have the ability to have Tanzu Kubernetes Grid service inside of vSphere with vSphere 7 with Kubernetes, and even those workloads can be attached to Tanzu Image Control as well. There's also an additional service called Tanzu Kubernetes Grid Plus. What this does is that it allows more open source components to be supported. You also get a little bit more of a handheld-like experience, where our customer reliability engineering team will be assisting you with not only the architecture, but as well as some of the upgrade processes for Kubernetes. So it is an easy way to get started, and it's a good way to kind of understand exactly how all those, how they can help you get started on that journey as well. And now that you know what's going on, let's go ahead and dive into a quick demo looking at the TKG CLI. The first step for having a successful TKG deployment is having the TKG OVAs imported into vCenter. There are two required. The first is a photon image that will be used for provisioning our clusters. This contains all the components for building Kubernetes clusters, in addition to vSphere's specific components for the container storage interface and the cloud controller manager. The second image is the HA proxy OVA. This is responsible as acting as a load balancer in front of the Kubernetes master nodes for having a scalable control plane and distributing requests upon multiple nodes for the Kubernetes API server. When running from a local machine, the only prerequisites are having Docker installed and the kubectl command line ready to go. Using the TKG CLI, initialize it, specifying the UI flag, and it will automatically open a browser, giving the option to choose to deploy to vSphere or Amazon Web Services. This demo, again, will be using vSphere 6.7 Update 3. Filling out the TKG UI adds all the environment variables into a configuration YAML file. Using this file or exporting environment variables into a command prompt using the TKG CLI is required for having a successful deployment. Utilizing vCenter credentials, we will pull all available information from vCenter to make this process simplified. Adding an SSH public key is required for accessing the deployed machines. The control plane setting allows a user to choose an instance type that will fit their desired deployment with varying sizes based on how many Kubernetes clusters that management cluster will be managing, or if they desire a single control plane deployment or using a production deployment with multiple control plane nodes. After filling out the remainder of the fields, click on Deploy Management Cluster. This process will create a local Kubernetes cluster on the local Docker daemon using a technology called Kind, or Kubernetes in Docker. This will deploy all the necessary components to this locally running cluster. After this cluster is instantiated, it will deploy a new management cluster to the vSphere environment, where it will once again deploy the cluster API components, including those controllers required for vSphere. Then it will perform a move, where the settings on the local cluster will be transferred to the management cluster now running in vSphere. This process will take several minutes to complete. After this process is completed, looking at the vSphere UI, the control plane and the single worker have been deployed because we specified the type of cluster as development. Now that the management cluster is ready, we can now deploy a workload cluster by specifying TKG create cluster and the accompanying flags for customizing that particular deployment. Going back into the vSphere UI, the first machine that is cloned is the HA proxy VM that will function as the load balancer to accept incoming Kubernetes API server requests for this cluster. If at a later time we could scale the control plane nodes to 3 and have the HA proxy VM be ready to distribute the work. Next, the control plane VM is created and goes through its process. Later, the worker nodes are then cloned. After cloning, kubeadm, which is an open source tool for easily clustering Kubernetes, is used to join them all together. Lastly, Calico is deployed as the default overlay networking solution for CNI. Doing a kubectl get nodes shows us that the cluster is ready to start accepting workloads. At the same time, the CSI driver for vSphere has been configured, and all that's needed to deploy stateful workloads is applying a storage class. At this point, we've created our first workload cluster. So if you want to get started, go to kubernetes.academy or kube.academy. This is a lot of online resources that we have. Easy videos to kind of get started, get you along in your Kubernetes journey. And then we also have the VMware hands-on lab. There will be a Tanzu Kubernetes Grid hands-on lab that is going to start being built. However, there's already 2 for Tanzu Mission Control, and there's already a Lightning lab for what was called Project Pacific, or it's what's now known as vSphere 7 with Kubernetes. So make sure you stay on top of the hands-on labs, and then you'll see a new TKG1 come out in relatively good time. So with that, I want to say thank you all so much for your time. If you have any questions, please put them in the chat. I'll be around, or you can find my handle on Twitter, ask me through there. With that, thank you for listening. Go check out Tanzu Kubernetes Grid, and start enjoying running your Kubernetes clusters. Cheers.